Hi, this is Michelle Cullen, and this is Astronomy 103A. Welcome to week 3, the sky and seasons. This week, we're going to get to learn about the night sky and what it looks like from your perspective, and to think of it from the bigger perspective from space. A useful way to think about the sky and to learn about it is using the concept of the celestial sphere. That is a concept of a dome that you can see in the sky with all of the stars that appear to be like a projector on that dome. Now we know that the stars are actually different distances. Some of them are farther and some of them are closer, but they all appear to be on this dome. Another important concept is that of your local sky. Obviously, if you're up here in Alaska, your local sky is going to be the stars that are up in the northern hemisphere. If you're down here in Patagonia, your skies are going to be seeing more of the southern sky. So this is really the concept of your local sky. And in our local sky, we have some reference points. We have the horizon, and we also have the cardinal directions of north and south, east and west. You could use a compass that has 360 degrees to locate north. It would be magnetic north, not necessarily true north. The way to locate true north would be to use the asterism of the Big Dipper to locate the Polaris North Star, and then that would be pointing in the direction of north. So we have these cardinal directions, and we can find the direction of any object by using it, going 90 degrees to east, 180 degrees south, 270 west, and back up to 0 north. Another useful set of directions would be the altitude. And altitude is the angle from the horizon up into the sky. And you can use it to locate very specific stars or objects. So if you wanted to locate a star that was at the zenith, you would just say it has an altitude of 90 degrees. If you're in Alaska and you wanted to find the Polaris, you would say that it has an altitude of from Valdez is 61 degrees because we're at latitude 61. If you wanted to find this star, its altitude is 60 degrees, and if you were pointing directly between south and east, southeast, you could say that it's southeast at 60 degrees. Here's another example of one that is similar. These astronomers are pointing at a specific star that would be southeast, this time with an altitude of 20 degrees. Here's something that's really cool. You should know this, and this is a big takeaway point from Astronomy 103A. That is the concept of the ecliptic. And the ecliptic is the path of the planets in the sky. And if you know that they always travel in an arc, and that arc is going to change with the seasons and change with your latitude, but that they're in an arc that goes from west to east, that the planets are going to rise in the east and they're going to set in the west, that you'll be able to determine if some bright object in the sky is an airplane maybe, or if it's actually a planet, because if it's on the ecliptic, chances are it's a planet. So that's really cool. And if you go out tonight, if you can see the stars, if you can see a planet, you'll say, aha, that's on the ecliptic. Another useful concept that astronomers use is a concept of angles to measure the distance in the night sky. The distance of the moon is 1/2 of a degree in the sky. Well, what does that mean? Well, it means that it's 360 degrees is a circle. 1 degree would be that size part of a circle, and the moon in the sky would be half of a degree, which we call that we divide our degrees up into arc minutes. So there was 60 arc minutes in 1 degree, and there's 60 arc seconds in 1 arc minute. So these are very, very small distances, but sometimes if you're looking at a telescope, which is going to let you see that really that one star right there in the asterism of the Big Dipper is there's actually two stars, and maybe they're separated by, you know, 2 seconds or something like that. So it's useful for astronomers to be able to say that. For you, the more practical point is that your hand is a reference guide. If you spread out your fingers of your hand at arm's length, it's going to be about 20 degrees. One finger is about 1 degree. Your fist is about 10 degrees. So you could hold out your arm, make a fist, and if you see the Big Dipper, try seeing it should be 5 degrees, half of your fist. It's a very useful concept. Here's the moon again. Really, it is only covering a half of a degree in the sky. So if you cover your finger, your pointer finger should be able to cover it.